In this lecture, we will be discussing how to solve linear equations involving decimals. The easiest way to do this is just to leave the decimals and follow the steps that we've outlined in earlier lectures. We don't have parentheses or fractions to eliminate. We don't have like terms on either side of the equal sign to combine. We want to get all of our variable terms on one side of the equation, all of our constant terms on the opposite side of our equation. We notice that all of our variable terms are collected on the right, which means that our constant terms need to move to the left side. To eliminate that positive 1.7, I'm going to do the opposite. I'm going to subtract 1.7 from both sides of my equation. 1.7's fall out on the right, leaving me with 0.3a, and on the left side, 1.2. Now that all of our variable terms are on one side and our constant terms are on the opposite side, we want to eliminate the coefficient of our variable. We're going to divide both sides by 0.3. The 0.3's cancel out to be 1a on the right-hand side, and on the left-hand side, positive 4. In this next example, again, we do not have parentheses or fractions to eliminate. There are no like terms to combine on either side of our equal sign. We want to get all of our variable terms on one side of the equation, all of our constant terms on the opposite side of the equation. In this problem, we have both variable terms and constant terms on either side of the equation, so we have the option of choosing which side to move the variable terms to. I'm going to move the variable term with the smaller coefficient. I'm going to move the 8m. It's a positive 8m, so I'm going to subtract 8m from both sides of the equation. 8m's on the left cancel out. We have 4.2 is equal to 2m plus 11.6. Now that all of our variable terms are collected on the right, we need to move our constant terms to the left. To eliminate this positive 11.6, I'm going to subtract 11.6 from both sides. 11.6 cancel out on the right, leaving me with just 2m. And on the left, we get negative 7.4. The last thing we need to do is eliminate the coefficient of m. I'm going to divide both sides by a positive 2, which gives me a solution of negative 3.7 equal to m. In this example, we do have parentheses in our equation that we need to eliminate. The first thing that I'll do is distribute the 3 to the right side. Three times x gives me 3x. 3 times a positive 2.9 gives me a positive 8.7. We don't have any like terms to combine on either side of our equal signs. We have both variable terms and constant terms on both sides of our equation. I'm going to choose to move the variable term with the smaller coefficient, which is the negative 5x. I'm going to add 5x to both sides. This gives me 6.3 is equal to 8x plus 8.7. Now that all of our variable terms are collected on the right, I must move the constant terms to the left. It's a positive 8.7, so we'll subtract 8.7 from both sides. That gives me a negative 2.4 is equal to 8x. And then the last thing we need to do is divide by the coefficient of our variable. We'll divide both sides by 8, which gives us a solution of negative 3/10 is equal to x. As I mentioned before, I really think that's the best way to solve these types of equations. However, there are later problems in later courses where we really don't want to have decimals in our equation. So there is a way that you can eliminate the decimal points. We do that by multiplying the equation by some power of 10. The way you determine the power of 10 you want to multiply by is the maximum number of digits you have to the right of any decimal point in your equation. So you'll notice that this 0.12 has 2 digits to the right of the decimal point. This one has just 1. This one has just 1 as well. So 2 digits to the right of the decimal is the maximum number. We are going to multiply then by 10 to the second power, or 100. When you multiply by a power of 10, it moves our decimal point however many zeros you have in that multiplier. But when I multiply this whole equation by 100, each of my decimal points should move 2 to the right. So that moves 2 to the right and becomes 12. Our next decimal point moves 2 to the right. I'm going to have to backfill in with a 0. This becomes plus 40w. Don't forget about the constant term or any term that doesn't have a decimal. We need to draw in the decimal and still move it 2 to the right and backfill with the zeros. This becomes 300 minus, again moving the decimal 2 to the right, 160w. And now we have an equation with no decimals in it. We proceed as normal. There are no parentheses, no fractions to eliminate. We don't have like terms on either side of the equal sign. So we want to collect all of our variable terms on one side, all of our constant terms on the opposite side. I'm going to move the variable term with the smaller coefficient, which is negative 160. I'm going to add 160w to both sides. That gives us 12 plus 200w equals 300. Now that all of our variable terms are collected on the left, we need to move our constant terms to the right. I'm going to subtract 12 from both sides. Gives us 200w equals 288. Lastly, we need to divide by the coefficient of our variable. We'll divide both sides by 200. Since our original problem was a decimal, we want to write our solution as a decimal. We end up with w is equal to 1.4.